So we'll now move on to the next presentation. This will be around the data clearinghouse. Who doesn't know Stephen White, put your hand up, but that's okay. But Dr. Stephen White from the energy efficiency leader for CSIRO. Stephen, the floor's yours.
Thanks very much, Tony. The big green button, yes, beautiful. All right, so this is the data clearinghouse activity, and so now we've moved from the design phase of constructing buildings, and we're now moving into the operational phase, and with a particular focus on data. So what I'll do is just give you a run through of the overarching sort of philosophy and just a few snippets of information, and then I'll call up my project leaders, and I've got a few questions of them just to sort of try and squeeze it all into an hour. So it's all founded on the basis that there is this thing that will be called the Data Clearinghouse. And the Data Clearinghouse will be a collaboration platform for people who have got data to transact with people who want to use data. So down there on the bottom are the data providers. It could be your building, which has got a BMS in the bottom and the data is streaming out of the building. It could be IoT sensors, indoor air quality sensors and the like. And third-party cloud data coming out of the cloud, such as the Weather Bureau, National Electricity Market, and the like. These are all the data sources. They're all disparate. They're all sort of flying around in the ether, and the Data Clearinghouse is bringing them together and putting them into one consolidated place. And then the data users are the people who are actually going to do something useful with that data. They may be providing supervisory controls, for example, flexible demand, or they may be providing energy efficiency services such as fault detection. The key thing here is the role of the Data Clearinghouse to consolidate that data and structure that data so that it's really easy to use. And in our dream, if you like, what we'll have is a self-service environment where people can click and download their app and be able to apply it with minimum amount of intervention. A long way to go. I think that is a journey for our industry over the next decade. But that structuring, we're using the BRIC metadata schema and VBIS for asset tagging. And that gives standardized ways of looking at the data. We've done a lot of voice of customer and focus group research looking at, well, what is the journey towards digitalisation there? And it seems to me that we can break it down into two steps. The first step is all around getting your building digital ready with its IT infrastructure and connectivity, and that's particularly difficult for existing buildings. And then the second step on the journey there is to actually deploy the useful value-adding applications. That's the fault detection, advanced controls and the like. And it seems when you discuss with industry the sorts of barriers involved, the second step there, typically fault detection has got payback times of less than 2 years. What's not to like about that? And perhaps the main barrier there for that second step is, well, for building owners to say, well, do they really care or not? That perhaps is, or customer interest. But when you look at the things that people talk about, whether it's cyber security, interoperability, just the general confusion about what I need to do to get my building onboarded, it all sits pretty much in that step one. And that is where the Data Clearinghouse is trying to address the problem. One of the people we talked to in the focus group described this as to actually try and do both steps all at once is a bit like trying to thread through the eye of two needles and to actually get them all sort of interlocking at the same time. And so ideally, I think what we'd like is some sort of landing point after the first step of the journey, which I'll call digital ready. And hopefully the Data Clearinghouse, at least philosophically, shows us a pathway towards that. So how does the Data Clearinghouse help? Well, one part, as I said, is around the consolidating of the data in one place and making it accessible there. Another part is putting the control of that data, the ownership of that data, if such a thing exists, in the hands of the people who actually own the data, the building owner themselves, and allowing them to select who they give it to and giving them streamlined, easy ways of doing it. As I said, it's also partly about providing the metadata around that so that the data is discoverable and easily usable, and a lot of that work is being underpinned by data standards, and we're working with the international standards bodies such as the BRIC schema. So that's the data clearinghouse's sort of the underpinning collaboration platform. But then in terms of the projects in the iHub Data Clearinghouse activity, we've got 10 separate projects there. And each project has got a site host, that's where we're doing the demonstration, and each has got a sort of a provider of a useful service in some way. And so I've listed down the site hosts and I've listed down the providers, and the colour coding there around the blue is, well, who's driving this? So in some cases we've got the host site saying, I need to get control of my data. What I'll do is I'll join up with the iHub Data Clearinghouse and I'll make my building available so that I can then access services. On the other hand, there were a bunch of people, well, I've got this software service and I'd really like to make it easier and cheaper to deploy. Why don't I actually do case studies, almost living laboratories, around my particular service there? And so here was our journey then. The first sort of 12 months or so, I guess, was around deciding on what would be our right platform and the development to make it fit for purpose. The second stage of our journey then was recruiting all these projects that you just saw. And now the third stage of the journey is all around the project delivery. And you can see the number of buildings that we've been onboarding over the journey so far. And now, come the end of the financial year, we're looking at 60 plus buildings sitting on the platform, ready to accept and use services that are available through the platform. But it would be fair to say that onboarding these buildings is never easy. So I've got this slide around getting the data into the data clearinghouse. You know, the data clearinghouse is sitting there as a middleware software platform in the cloud, ready to receive data, but someone actually has to provide that IT connectivity that I talked about from site. Now, particularly with a focus on the building management system, it could be that you have a native BMS that is already grabbing that data, pulling it out into the cloud, and all you have to do is ask, and ka-ching, it's there sitting in the data clearinghouse. We had none of those projects. I wonder why not. Maybe something to do with lots of legacy hardware out there, and a little bit to do with whether or not people who have already got the data, the BMS provider, is actually willing to then on-share it. It could be that you have software just sitting on a site server, and in this case, you know, you're utilising the existing infrastructure there that the actual site owner already has, and so if it's a zero capital cost almost, but then there are issues perhaps around the skills to be able to maintain that as a site provider there. We had one project, I think, that I would say sat in that space of software on the site server. Then the next one, the hardware gateway, you go in with the Tritium JSON or the like there, and there are a number of products that are available there, and that actually does that interfacing between the BMS and getting it out into the cloud. And that's probably a relatively straightforward, robust approach, but you do actually have to pay for the box. You know, it's debatable whether people are willing to pay for the box. And then the last one is just to API out of someone who has already captured the data and the data is already sitting in the cloud. That's relatively easy, but it just doesn't get around that problem of getting into the building. So we had a couple of projects with API where the building owner actually preferred to get a first entity to pull the data out, and then Data Clearinghouse became almost a secondary store for the data, but most of the projects were around hardware gateway. Oh, sorry, and I should have mentioned there that in our case, what we're also trying to do is do that metadata structuring, which is not standard practice in the industry. So just a quick run through then of some of the outcomes that we had in the project. I think one of the things that I'm quite proud of is a plug and play IP MVP Option C measurement and verification app. We have trouble issuing of white certificates and things like that when it's anything more than just to sort of throw out some lighting retrofits or something like that. We need simple, easy ways to validate the energy savings that we've made, and that's particularly tricky when it comes to things like fault detection and controls solutions. So this is a downloadable app. Literally, if you're sitting in the Data Clearinghouse, download it from the Play Store and then install it for your building, and ka-ching, off it goes, and gives you how much savings you've made. We getting more operational on the devices. We created a model predictive control battery algorithm for deciding when to charge and discharge batteries based upon forecasts, and that's been operating since late last year, giving 6% bill savings, predominantly from the demand tariff, not from the energy portion. We've deployed energy analytics in buildings, and that's identified energy savings, weasel word, identified. It still relies on the end user host site to deploy it, so we haven't got the validation, if you like, of that. We have had a chiller scheduling app deployed there, and that's probably one of my favourites of the projects because this really demonstrated the power of what we're doing. That is, project approved, API handed out to Exogenics, the chiller optimization company, back with the AI done on the data, and savings identified and implemented all in months. And considering how long some of the projects take, to have a kind of that feedback response in months, small numbers of months rather than years, is actually an incredible outcome. And it demonstrated maintenance benefits as well as energy benefits. And then a lot of work on the flexible demand, some demonstrations that are just sort of getting the results in now, but a lot of work trying to prove up what the resource is in Australia. So here's our predictive battery control app. What you can see there is the forecasts, both for the PV generation and for the load there, and then the scheduling that goes on. And the apparent peak demand that's happening in the morning, there, the algorithm says, no, we're not going to discharge the battery. Looks like we should, but we know that there's going to be something coming up later on in the day, and so the discharge happens at the end of the day and keeps the total peak demand down. This one is a chiller response to a thermostat adjustment. In the bottom of the plot there is the forecast of the price in the NEM, and then the signal to switch the thermostat there. And then you see the result in two different trials, the blue and the orange there, showing the response of the chiller or the air handling unit in response to the thermostat adjustment. And what you see there is that the actual dynamics of this is not the building thermal physics. When you're looking at this time frame, it's actually more based on the actual equipment plant itself and the PID loop around the controller there. So there's a fair bit of nuance there that we'll be teasing out in some of these strategies for flexible demand. It's not just a straight straight down, flat, straight back up again type profile. On the resource assessment, we did a top-down. I've presented this before. This is looking at a network-by-network basis and looking at the variation in consumption based on ambient temperature, and deducing, therefore, how much air conditioning there is, and subdividing it by residential and non-residential buildings, and then how much demand response we could achieve. Previously presented that is in the order of 6.9 gigawatts of air conditioning load in residential and 1.5 gigawatts in non-residential buildings across Australia. So you could just switch that off and you've got large amounts of emergency peak demand reduction. But if you want to be more subtle about it and use thermostats and stuff and not interfere with people's comfort, then the market DR column there is the savings you would get from adjusting thermostats. And one of the big unknowns that we'd love to test at some point in time is around, well, actually, can we also call for our air conditioning systems to start consuming more when we've got an issue with too much solar in the network and the need for solar soaking? And so that was kind of the top down, looking at it from a total disaggregation of our total energy consumption. Now we've flipped it around and gone on a building by building sort of basis, looking at how much HVAC plant there would be in the basement of a building, all the buildings in Australia, and how much sort of on a site-by-site basis you might be able to extract. And we've done this using Energy Plus modelling. We've done it for schools and offices, and you can see there's substantially more kit sitting under the bonnet, if you like, to take a car analogy, in terms of power to consume or power to reduce than that maximum after weighted after maximum demand. Get my acronym right there. And so I've given two data points there. One is around the hot temperature, 3 o'clock in the afternoon. This is when you're likely to be shedding demand. And then the other one is on a relatively mild temperature in the middle of the day when you'd want to do some solar soaking. And so the difference between what's actually under the bonnet and what you're consuming actually gives you some idea of how much solar soaking there is available out there from schools and offices by themselves. This sort of amount of energy flexible demand as a capacity product is worth in the order of $300 million per year in reduced energy bills. And the modelling sort of showing, if you like, the intensity of demand response potential. So in the order of 2 to 6 watts per metre squared of flexible demand potential from thermostat adjustments. So just to conclude, before I call up my, my project leaders here, so the data clearinghouse, it's now operational. We've got tens of buildings on there, should have 60 by the end of June. And ready to, if anyone's got buildings or apps that they want to put on the platform, ready to talk. Obviously plenty of experience around the time and heartache it involves to actually get a building on board. That's to bring it to the state of digital ready. And in a sense, that difficulty reinforces the barriers, highlights the need for the data clearinghouse as a sort of a step on the journey to gaining flexible demand and energy efficiency benefits. We've got a bunch of softwares that have been trialled on the data clearinghouse that are demonstrating real flexible demand and real energy efficiency savings, and more to come. And I guess I just leave you with, this whole work has been sponsored by ARENA, and flexible demand is a core topic for ARENA, and just pointing out that flexible demand is both good for the property industry and good for the electricity industry as well. For the property industry, I see it as part of the electrification journey and the journey to net zero. And for the electricity industry, it actually saves cost, improves the efficiency of our electricity market. So hopefully that gives you a bit of a flavour there of what we've been trying to do. Whistle-stop tour, I know, but I do want to give time for all our project leaders. So if I can call them up, we've got 3 seats over here, and Marie's got the microphone. and I'll just ask some questions. Just to tease out a little bit more about the journey that we've had in the iHub project. Sorry, so guys, you can come out. Mehdi, TK, come on, Subu, Anna, where are you? Danielle, Adrian. And bring a seat. We've got... oh, well. So perhaps I'll start with you, Adrian. So Adrian Michaels, Managing Director of HFM Assets Consultant. Lead consultant, yep. So Adrian has been working with Property New South Wales, Nihan, yep, great, in DCH4 there. And I guess if I could ask you guys, you know, where are you seeing the benefit and the return on investment from investing in the IoT platform that you've been working with?
Sure, thanks, Steve. I guess...
I think that's on, yeah.
Is it on? Okay, good.
Yep.
I'll start off and Nihan may jump in. I guess initially with, so Property New South Wales owns and manages a large range of office properties all across New South Wales, in which various government agencies reside. And a lot of those buildings are in regional country areas of New South Wales, all over the place. There are a wide range of ages, from properties built in the 1950s through to modern, recently built properties. One of the initial things was getting visibility of sites and looking for, so what started off originally as we had, you know, Property in New South Wales, we had lots of buildings that didn't have BMSs, didn't have visibility, were difficult for FMs to have visibility of, understand what's going on. Was started off as, well, we need to get data on those buildings and we need to put it into a common, easily accessible platform. And so we developed the requirements around, well, if we're doing that, we also want to make sure that we can analyse the data and optimise operation in more complex buildings. So where we have buildings with BMSs and those sorts of things. So I guess the value proposition was leveraging the fact that we're going to have lots of data coming into the platform. Now, do you want to add anything?
I think, yeah, so Adrian's covered most of it, but thanks. But I think regarding IoT, the whole point was to give tenants the visibility and the access to the portal as well. Earlier, they were just raising some issues. They didn't have enough information about what's happening. A lot of problems were going unnoticed and underreported. Now they have portal access. They can easily save time, not just for them, but for us, the contractors. Issues get raised straight away, no matter how small they are, and they get rectified straight away. So yeah, that's why we thought, yeah, investing in the IoT platform would be a, you know.
So it wasn't just energy, it was other things as well.
Yeah, so it was about thermal comfort as well.
Yes.
So, and it's about delivering a higher level of customer service to all our tenants. Yep. So yeah, we did try to capture a whole heap of things.
Yeah, cool. Thanks, Nihan. Danielle was very enthusiastic. She responded to my email. Caught in traffic, yes. So Anna Hansen, Managing Director of Buildings Evolved. So you are involved and in the New South Wales Schools New South Wales project. Can you give us a bit of a sort of a vibe as to some of the issues around data collection that New South Wales schools were facing?
Yeah, hi. Yeah, look, very similar to Property New South Wales in terms of the portfolio. New South Wales Schools has around 2,300 sites, obviously scattered across the state by population. So there's an enormous diversity in that portfolio as well. So, for example, we've got buildings from 1870 all the way through till last year, and an enormous diversity in that portfolio in terms of technology that we find inside the schools, and also, I suppose, a fairly challenging environment in terms of what's happened there in terms of air conditioning system installs over many years. A lot of it was not, it was sort of done, I suppose, through initiatives from PNCs and schools independently of the central department. So, however, that all changed recently, so that's one of the reasons why we initiated the DCH6 project, was because New South Wales government decided to invest $500 million in air conditioning installs across the state. And so that then meant a standardised approach to the installations, and it meant an opportunity to do more. However, the specifications that were released for the Cooler Classrooms program had no connectivity, but had PLCs in each classroom. So we had this sort of odd scenario where there was lots of data, but just not really readily accessible.
Lots of ability to control.
Lots of ability to control. And lots of data going nowhere, that was the other part of it too. So lots of data just ending up just disappearing, evaporating, really.
Yeah.
So the challenges there have been really around, I think, articulating the value proposition to the department and to the schools in general. I'd say this is a big problem that faces the industry as a whole, and a lot of the difficulty that we have in getting these projects off the ground are really in relation to explaining that value proposition to key decision makers within organisations. If they were more excited about the projects and they understood the value that we were trying to bring to their organisation, their operations, then I believe that they would be far more enthusiastic about.
Anything to say about inverter manufacturers?
In what sense? Sorry.
Data access.
Oh, right. Yeah. Well, look, you know, the Department of Education has an interesting policy there. They specify only SMA and Fronius because they want to have local Modbus capability to grab data out of the inverters, and they also want to limit the number of cloud platforms that they're putting data into. That was actually broadening out their policy. Previously, it was just SMA. So they have had this sort of data-centric kind of view to the way they want to do things, but just without sort of, I suppose, a master plan as to how it was all going to piece together. So that's I think what the DCH6 project has really brought to the schools, is a bit of vision and a bit of direction as to what they could potentially do, and a lot of the work that we've been doing alongside the technical elements of it in terms of data connectivity has really been around the financial modelling elements and trying to explain that narrative of the value that we can see in demand flexibility.
Thanks, Anna. And TK, so TK Wang, account manager at VBiz there. Can you tell us a bit about the onboarding journey with City of Melbourne buildings?
Yeah, so City of Melbourne was quite an interesting client to onboard because of the range of buildings that they actually operate. So for the DCH7 project, we looked to connect to five buildings in their portfolio, and this included 2 libraries, 2 childcare, daycare sort of community hubs, and 1 visitor centre. So we've had a range of buildings, both in terms of size, in terms of complexity, also in terms of age. So there was 1 building that was only just completed as we started doing our works, and we had other buildings that had been around for a while and was actually about to go through upgrade processes. So the onboarding journey for these buildings has actually been quite challenging, mostly because of what I think Stephen had already covered. There was the data collection piece in a lot of these buildings is actually quite challenging, especially working with facilities teams that often heavily rely on their contractors to provide that information. So to go through them to try to get a lot of the technical details about the buildings to connect to it required a lot of groundwork, a lot of legwork to go to the sites and actually extract that information. Similarly, in order to build a data model for a building, there's actually a lot of information that's required that isn't seen in a typical schematic. So these could include the type of asset it actually is. Rather than knowing, most buildings would know there's 3 chillers on site. what sort of chillers are they, how do they interact with other systems. That's a lot of that information that's currently missing in a lot of the data models. So even within the where Vibas were able to really help supplement the brick model was to provide some of that clarity, but it also meant that having to go to the site to actually look at the nameplates to try to extract that information required quite a lot of effort. And you can see how, at a macro level, how this could really stop building owners from engaging down the data path, the digital path, to try to optimize their sites, because it very quickly falls into it's too hard. Right? There's too many unknowns. I have to rely on my contractors, and not only that, because we are crossing specializations, so whether it's through PV or building management systems or other systems or IT networks, every contractor has a very narrow focus on what they provide, and to have visibility across all data systems is challenging and requires a lot of negotiation with different people. So.
Beautiful. Thanks, TK. I'll pass on to you, Kaveen. So Kaveen Ardren, Managing Director of Delta Q. So you've been talking with the energy retailers there, and what are they saying they need in order to be able to offer flexible demand as a product for building owners?
Thanks, Stephen. Not sure why I'm talking to retailers. It's always dangerous. The DCH3, we're looking at the opportunity to obviously tap into existing buildings with the capability to play in the wholesale demand flexible market. In the discussions and working out, is it financially viable, etc., we've landed up talking to a number of providers of this, many of which are retailers, who are acting on behalf of landlords who normally don't have either the registration as a market participant or the knowledge to be able to play in the market. So the retailers are coming in and saying, well, we can do this on your behalf. But in order to do that and to be on their behalf, they need to have better understanding of how the facilities are operating, what's the position of the building in terms of its, I want to call it thermal inertia and other aspects of it, as to is it ready and can it actually respond and switch things off or turn generators on, etc., to be able to say, I know with high levels of confidence that I can actually participate in a demand event. And so therefore I can actually make some money out of it and keep going down that path. In order for the retailers to be able to get that information, as you can imagine, they don't have any insight or any visibility of how those buildings are operating. So what they need is some platform which can give them a view of those buildings, of particular aspects of to how it is positioned at that point in time, as well as long-term trends, to understand, okay, we've got notification of an event that's coming within the next, say, 2 hours. Is this building in a position, and are its systems in a position to be able to respond? Because then they know how much they can commit, because you may or may not know when they're trading in the wholesale market for demand or FCAS, they're having to respond in some cases in a very short time. So what they need to know is understand, not only is one building, but is this whole suite of buildings that they're looking at, because they are trading in the wholesale market on an aggregation of a number of buildings that could all participate at the same time. To be able to say, I've got 60% of all my sites that have agreed to a certain level of commitment that they can participate, and in order to do that, I need a consistent model of that data in a way that I can understand and interpret consistently across all those sites. So therefore, to have a single platform with a consistent model allows me to be able to then interpret that data, understand any thresholds that I may need to deal with, and therefore be able to give me a signal as to whether I can participate or include that within my bid that I'm going to take to the market.
Certainly in a lot of the work, customer discovery work that I've done, that sort of word certainty just keeps coming through and through and through and through. And so on the electricity side as well as the building owner side. Thanks, Kaveen. Pass to you, Mehdi. So Mehdi Syed Mahmoodian, Associate Professor in Electrical Engineering at Swinburne there. So you're developing a transactive energy management app. So what's that, and how do you think that that's going to help with that sort of more portfolio or community level approach to energy management?
So I'll answer your second question, then the first question will be answered. In the operational level of building management system, originally we were thinking about, in order to make a building efficient and achieve the net zero target, we have to focus on the demand, and then we should have the energy generation on site. However, in the urban area, when we have a small lands and we have large buildings and we have big loads, we need to actually focus on the third element, which is the transactional cooperative approach, in order to share the energy between the different buildings and between the different communities. In order to achieve that, you are using the third element, you are using energy as a currency. And this will bring a win-win situation for the end user, which are the buildings, in order to actually make the buildings efficient, use less energy, optimized energy, use the on-site energy generation, and also help the grid, which are on the other side of the story, in order to reduce the peak demand. What we did in this project, we actually tried to cover all of these three. So we actually used the game theoretic approach in order to manage the demand on site. Obviously, HVAC system in the institutional buildings accounts for around 60% of our demands in particular time of the day. So we manage the demand considering the forecasted loads, forecasted temperature, forecasted weather conditions. We actually brought in the timetabling, so we knew the laboratories, offices, and also the classes that we had on the site. And also we actually used the occupancy rate. So we knew the number of occupants inside the building. We used the sensor diagram to count the occupants inside the building and change the set points accordingly. On the generation side, we actually used the solar panels plus the battery management system, which would actually create that energy market to see whether they can actually use that energy better off in terms of financial aspects, better off to actually use that energy inside the, that specific building, or is better to actually sell it to the grid or to the neighboring neighbors. And in the third elements, we had another building. So we had, in overall, we had two buildings. We wanted to show that transaction. One of them had only a storage system. The other one had storage and solar panels. So we actually created energy market so to actually sell the energy to the neighboring conditions. So when you have energy, you have three options. Use it on the microgrid, sell it to your neighbors, or actually sell it to the grids. And we try to actually achieve that, obviously, until the last days before this presentation. What we realized within these scenarios, so is actually now fully operational. But what we realized, there are three elements which are very important. Flexible loads. You really need flexible loads in order to achieve the ideal scenario. And also you need it's much easier if we actually plan in advance in our building designs and in our electrical circuits that we do in our buildings. It actually reduces a lot of system. And also it should be a willing from the building operator to give you access to the data, or to actually let you install the sensors and sensor diagram into the building to get the data and then manage it.
Have you got any numbers in terms of expected or achieved energy savings?
Yeah. So in one of the buildings, it's actually massive buildings, we have 8 zones. That 8 zones of HVAC system, obviously they were constantly operating throughout even COVID. So even when we didn't have any occupant in the buildings, all of the 8 zones were actually operating. And there was no what's called use of the on-site energy consumption, energy generation. So for all 8 zones, we are predicting around 80, actually for 8 zones, we are predicting around 240,000 energy saving, which is actually very what's called big number. And this is, we calculate based on the 2 main zones, 80,000 per year savings. So we predict around 240,000 savings for the institution.
Beautiful. Thanks, Mehdi. And passing to you, Subu. So Subu Setyavenkatraman, Group Leader in the Energy Systems Program in CSIRO. I guess first, I mean, if you'd like to have a response on some of the difficulties that the different sites have had in terms of getting their IT connectivity and how that impacts on you on the data clearinghouse side of the projects.
Yeah, I was about to respond to that. Yeah, I think, whenever a sub-project partner was talking about challenges with conducting their buildings, I think it's not really on the building side, it's also on the DCH side. But the beauty of developing a digital infrastructure like DCH is, once it is done, we can use it, in a repeatable way. Once it's done, that driver or, that hardware or a firmware becomes available for further building integration. So I think we have come through a learning curve, and we are obviously expanding the capability of the platform. And if you are going to have buildings of similar type, with the similar hardware, it's going to be a lot more easier now to ingest data from them or onboard those buildings.
And so, what do you see as success going forward for the data clearinghouse?
It's a great question, Stephen. I think success for DCH or for any platform, I think, is the impact that we deliver, and the impact pathways for a digital infrastructure like DCH are multiple, and they all obviously depend upon different time scales and also different market factors. I can probably say a few opportunities that we are currently looking at. One is obviously the large-scale industry adoption, and as we hear here, we already have over 50 buildings or 60 buildings, which includes not only the partners here, also some of the commercial partners who have already signed up with us to actually ingest data and make use of applications that are available in DCH, and increasing that industry adoption would be one of the impact pathways. And obviously, industry partners would be looking for commercial viability, and we are trying to make sure the onboarding cost, the onboarding barriers is actually reduced to easily provide them commercial viability, and also having a critical mass of buildings and applications so that people are seeing benefit in talking to DCH or interacting with the DCH. The second opportunity or the impact pathway is, as you mentioned, Stephen, is looking into implementation of large-scale energy efficiency initiatives from the government, whether it's state or federal, looking into using DCH as an infrastructure for proving those savings, or using, for example, using easy deployable M&V app as a way to verify energy savings. So basically a way to demonstrate impact through government building initiatives. That's certainly one opportunity. And probably the other one is DCH is a digital infrastructure, and it could be used by researchers and innovators. And once we have got data, we could be providing reference data for researchers to use, and also for innovators to use, and also making DCH available as a platform for testing new technologies like demand flexibility from buildings, and also for all type of digitalization trials in buildings. So these are the three potential pathways where we can deliver impact, and that will be the success story for DCH.
Thanks, Subu. Perhaps I'll open it up to anyone that would like to respond, and as many as feel able. Well, what is the most useful learning that you've got from your project so far?
I think and following on, I guess, from the schools example is, I think we found generally working through the various data sources and onboarding data, and then in terms of onboarding from the IoT, Property New South Wales to DCH, that was a cloud-to-cloud connection. That, I think, technically was relatively straightforward. I think there was a few different things of how to handle new data when it came on board and those sorts of things. I think the modelling of the building and understanding the relationships between the air conditioning plant, the tenancies, the zones, what that meant, that data, in particularly with existing buildings, can be very problematic, and particularly quite, you know, in our case, a very wide range of buildings, some of them very old, without on-site FMs and those sorts of things. I think that was still quite a challenge to understand and to get that understanding, so then the model could be built in the of what the building actually looks like, the relationship between the data and the physical.
Gamedi?
It's actually, I feel that the main elements in order to actually achieve the ideal scenario is onboarding the building operator. And what we notice, being in the very robust, high inertia institutional buildings, that is really hard to, you have to actually make different team happy to just do a small changes. We realize that data visibility and understanding the data plays a big role. So there is a hidden capacity in every building to actually make our nation closer to the net zero target. But this hidden capacity is not known with many of the people, even those who are working in the same sector. So I feel that data clearing house can be very powerful to provide this visibility, this understanding of this hidden capacity for each building, and onboarding the providing a willing for the building operators to participate in such activities.
Cool. Thanks, Mehdi. The term hidden capacity. Yep.
Just following on from what was been said here, yeah, I think the way that you engage with the organisation that you're dealing with is extremely challenging, and can, especially the larger organisations and government and so on, can be, as you were saying, you've got to please one stakeholder and another one and another one. And I think in your diagram, Stephen, you're saying you've got to line up the eye of the needle and the thread. But actually, I think there's three needles in the first section. You know, yeah, so, you know, what we found in dealing with, say, for example, Queensland hospitals with Metro North Health was that the operational team is extremely separate from the sustainability team and the property team. And to the extent that the sustainability team will have access to every single data set for the hospital, but for one, which is the operational data. They will not have access to any of the operational data. So there's organisational barriers. So organisational barriers within the organisations. Oh, that's that person's responsibility. That's IT's responsibility. That's this. That's that. And you know, through many years of doing this, it inevitably is that you have to go straight to the decision maker at the top, and they're the ones who can sort of manage to coordinate all of those departments that are integral to getting these things over the line. So that initial organisational inertia is extremely challenging, and I think, you know, Stephen, I think you've said in the past too, you know, and this is not quoting you or anything, this is not, but you know, change is really hard. Change is really hard. To say to someone, hey, we'll just go install some air conditioning in the school or what have you, you know, everyone can get their head around that. But to say to someone, oh, we actually want to do some flexible demand and you know, control your generation and storage and through some esoteric cloud platform is just is really a leap for a lot of people. And you know, again, coming back to that organisational inertia too, there are some people that just get those concepts that immediately will grasp and understand what you're trying to say. And then there are just people that will never understand what you're saying, and so that's actually probably one of the biggest problems. Which is why I always come back to value proposition is the cut through, because you know while obviously the hospitals have their objectives, which are to save lives, and schools have their objectives to improve educational outcomes. It's not always driven by money. But money is the generic cut through for everyone. So That's why we tend to go to the business case and use the business case as our battering ram to drive through change.
Interestingly, in some of the focus group work, it seemed that people sort of fell on one side of the fence or the other in regard to digitalisation. And the question, does digitalisation simplify your life or does it make it more complex? So just adds complexity, don't go there. And then others look at their mobile phone and is their mobile phone simple to use? Does it actually help them to get tasks done? The answer is yes. And you know, even the youngest child is sort of tapping away, doing incredibly complex stuff because it's made simple through
I'm the man that pulled out a book on the plane this morning, so, you know, so I can get behind non-digital forms of things.
Any other responses on learnings from the projects?
Yes.
TK?
So I think taking on what Andy actually just said, right, was different stakeholders have access to different data. And while I suppose our project had some, went through a bit of effort to collect a lot of that data, once you do have it, it then becomes really useful because you've committed the effort, you've done it once. Anyone who actually wants it moving forward can actually query a model and start to extract that information. So I think it's one of those, while it might be a bit of work and planning and negotiation with all the various stakeholders to get them on board, the potential for what you can do with that data then becomes that much more powerful. And I think the second learning that we really had was then around how do you query a model. So part of our project was around the concept of redeployable apps. So one of our project partners was Predict, who was there to write the redeployable apps, to query the model to make sure it can be deployed in multiple buildings. And I think one good lesson that we had in that and working with the CSIRO team and the software application developers was understanding that why were certain queries being asked? Because while it sounds really practical when you just say it out loud, how you get to that answer, there's 10 different ways to try to get to that answer, but there might only be one way to get a consistent answer across all your project, all different models. So there is going to be a slight shift in terms of how we all think and how we all program and how we deploy applications in order to make sure that it is consistent. We do have that consistent response out of these data models so that we can have repeatable results.
Cool. Thanks, TK. Kaveen?
Yeah. Sure. I think one of the things that is probably a bit more of a relearned lesson is don't assume that your initial expectations or assumptions are correct. And so when we start talking about all the issues of trying to deal with change and the organisations you're running into, and having to take a potential client down a path where everything to them is just, it's not because they don't want to do it, it's just they don't understand enough to be able to take on that. Look at it with a different lens. And as I say, we found from my example, we could spend a month of Sundays trying to educate the landlord about how the market would work for wholesale, what they need to do to register and all the rest. And there's a simple answer. Find the retailer or somebody else who's outside of that who can actually come in and give certainty to that landlord without them having to worry about it. So sometimes you can partner with others who can take on the risk and who can take on and provide some level of certainty which helps you step around the barriers that are there. So just have a different lens as to when you run into those obstacles, there might be another way around.
Thanks, Kaveen. Subu, yeah?
Yeah, I think, it was a really fascinating experience working with all the partners in terms of how they want to engage with the DCH data. I think if I take CSIRO property as an example, we have got about 10 plus buildings and we do closely work with CSIRO property services. And they've kind of come a long way in the last 2 to 3 years. In the initial phase, it was all about, can you give me good quality data? Can you give me clean data? Do I have access to data cleaning tools? Do I have access to data health dashboards and things like that? But over a period of time, they are now wanting more and more out of data. Are you able to provide me advanced applications? Are you able to provide me, comfort band, display and things like that? So I think when I look at, how people interact with the data, I think, they certainly want to make sure the basic elements like, data quality and data availability needs to be really made sure before they even start looking into advanced things. But when it comes to advanced things, oftentimes I have seen they don't know what they don't know. So they certainly seek advice. We have regular calls with them, and the conversation starts like this. Look, we have got data. You guys have been pulling data for over 2 years. What can you tell us? They don't know specifically what they want. They probably want inputs from us, and I think that's probably going to be part of the journey as well. Figuring out how can we really add value to clients, with the data that's already available in the data clearinghouse.
And that's probably the catch-22, isn't it? Sort of what Anna was saying is, go to the value, absolutely, but at the same time, you've got to know what you don't know in order to sort of extract that value. So in our last remaining minutes, if anyone would like to give us a bit of a window on what's getting you excited in the digitalisation space in buildings. Could be a technology thing, or a particular product, or a value stream, or...
Yep. So
Go TK.
So with my initial background is more in technology. So for me, it's always been about how these technology systems are now coming together. So we have, even if we were to look at venture capital going into property right now, it's exponentially increasing. So in the coming years, we'll be expected to see a whole raft of new services and new products and new ways of thinking, similar to what I suppose we're doing here with iHub, trying to build a framework in order to build the foundations for new enterprises to come on board and develop new ideas from that. So I think for me, the digitization space, it's not necessarily about any one thing. It's about the potential of what we don't know that's yet to come. That's probably the most exciting thing.
You're an optimist, TK. Excellent.
Just building on what you say, I'm very similar to you, I'm a technologist, and I believe passionately in technology. You notice all the things I've been saying here today have not been about technological problems associated with getting data onto platforms, because that's not the problem. Well, it's certainly not for me anyway, and I'm sure for most of the people here. That's not the issue. The issue is not that. I think what I see is, just to build on what you're saying there, is I see this sort of like the beginning of the IT industry, where the IT industry had coalesced around standards coming from all these ridiculous vendors with all their ridiculous proprietary protocols. Which, does that sound familiar, anyone? And so I see some really exciting genesis or crystallisation of standards forming that are really going to be the bedrock of this industry. And when I say this industry, what I mean, this industry is optimization against all these different variables, particularly things like wholesale electricity and weather. So reinforcement learning algorithms, machine learning algorithms, MPC, AFDD, all of these things I think are just on the cusp of exploding into the real world, and then bringing real benefits to the network and to the users.
Exciting. Last comment, Sue?
I think I'll probably talk about the ability of digitalization to open up buildings as a resource on the electricity market. So far, buildings were standalone things, and people were worried about only energy efficiency, net zero, all that. But with access to high quality data, we can now, participate in the energy market and, deliver grid services. That's probably the most exciting thing, and that will probably, add new dimension to how buildings are as seen and operated in the past century.
I can answer this. In the building and end user or consumer side, we've seen always the research or the works on either side of this spectrum. So we normally focus on the consumer side, and we never consider what's the problem in the DNSP, energy providers, and so on. So the digitalization actually provides this translation between the consumers and DNSPs. It actually reduced the inertia that the DNSPs have in order to actually integrate more renewable energy into the grid, because that's the main problem that we have in the energy integration, in the energy efficient buildings, where the DNSPs and regulatory organizations don't have this willing to let the buildings have more renewable energy, more sustainable energy resources. But this digitalization provides this translation for them and provides and helps them to actually participate more of these what's called sustainable energy resources into the market.
Awesome. Thanks, Mehdi, and thanks to everyone. This is just a sample of, about 6 of the 10 projects here, so you can see there's an awful amount of stuff that's happened, and so feel free to catch up with them in the break after this to get more of the learnings. Because there's an absolute wealth of information in these brains around this world of digitalisation that's coming upon us. Thanks very much, everyone.
Just as people are going back to the seats, it was really good to now put a name to a lot of the faces. Certainly, for me anyway, the number of contracts and engagement letters we sent out was really good to now put faces and names together. That was great. The other thing which sort of, certainly from my perspective, is the number of types of buildings, the spread of what we've been doing, again, from aged cares to swimming pools to hospitals to childcare centres and so forth, even in Indigenous community up in the Northern Territory. It's quite a wide range of activities that went through there. We're now going to have a break for the next roughly about 15 minutes. If you want to go outside, get a cup of tea, coffee and so forth. Then we're going to come back and we're going to hear about the living labs. And from then we're going to have a bit of an open forum. We've already got some questions that have been sent in from various people already, so we'll be exploring that. So let's say 15 minutes, but I know you'll take 20, so let's say 15.